Hi, I'm Dr. Rory Smith, and we've all heard a lot about the Internet of Things, and it all sounds wonderful. But I'd like to really look at, is all the magic that we hear about true, or is it all a myth? So let's take a look at that. What is IoT? Well, IoT is the Internet of Things. And here's a graphic from about 7 years ago. It shows all kinds of things, not people, but things connected to a cloud. So you have communication from a device to a cloud that's automatic. That's the Internet of Things. But some things have been changing, and the definition may have broadened a little bit. So, question that we need to answer here, because things have changed, is a cow a thing? Well, here's a cow, and it's connected to the internet through that monitoring device that's around its neck. So is that cow a thing? And the answer is no, it's not a thing, but the Moo monitor around its neck is a thing. So it's the same as if you're wearing a health monitor or a fitness monitor and it's pushing data to the cloud. You're not a thing, but your health monitor is. So there's a lot of information about IoT, and it's everywhere we go. It's on television, it's in magazines, it used to be at airports, but most of us don't go there too much anymore. And so, but there's a lot of information. One of the companies you hear a lot about is GE Predix, because they're working with the Lift company. Another one is Microsoft, which everybody knows about, and they're working with two Lift companies. And then there's IBM Watson, for sure they're working with a Lift company. So there's also some slick videos. This was one produced by Microsoft about lifts. And there's even a magazine called the IoT of Elevators. It's published in English and Spanish. It's actually a very good magazine. And all of these publications and media outlets are telling you that it's fantastic, that anything can be done. Amazing things can be done with the Internet of Things, with machine learning. And, it's all true. It's all true, what they say. However, and it's a big but, they're talking about the potential of IoT, what it ultimately can do. Not necessarily what it can do right now, but what it can ultimately do. So it's not a lot of lies. It's all true, but you might have a hard time getting all of those things to happen in the near future. So what's important when you're dealing with IoT? Because you're essentially connecting your lift or your escalator to the cloud and doing something. Well, you have to determine what data are you gathering, how much data. Data scientists will tell you there's never too much data, but there are limitations on the cost of gathering all that data. You have to look at how are you processing the data? What machine learning algorithms are you going to apply, if any? What are you going to do with this data? And then in the end, when you have this data, you convert it to information. What do you do with the information? If you gather the data, if you process it, and then you do nothing with it, well, it's a complete waste of time. So these are the questions that you have to answer before you go very far in the Internet of Things. So where we are currently, the industry is applying Internet of Things technology is in the area of maintenance. Now, makes a lot of sense because maintenance is where, well, that's where virtually we make all of our money in this industry. So it would make sense to try to improve our most important product, our most profitable product. And so there are various types of maintenance, and let's review the history of those types of maintenance, and maybe that gives us some light on what we can do with machine learning, with IoT, and what we can't. So initially, all we did was breakdown maintenance. The lift would break, and we'd send somebody to fix it. And some people say that's all we're doing today, but I hope we're doing better than that. Then there's preventive maintenance. Now, preventive maintenance came about in the early 1950s. It was developed by the U.S. Army, and the idea was that if you maintain your equipment, even if it hasn't broken, it's ready to use when you need it. And this concept went over very well with industry worldwide and with the lift industry. And so everybody has gone into preventive maintenance, And it's still like the core of all maintenance that we're doing today. In the late 1990s, it became something called usage-based maintenance became very fashionable. And the idea with usage-based maintenance is we don't just maintain everything at the same level, that we adjust the level of maintenance based upon the level of usage. Well, makes complete sense, but it's not high tech. It's no different than changing the oil in your automobile every 10,000 miles. You're based on the usage of your automobile, you change the oil. It can be much more interesting than that and more productive if we, for instance, monitor door cycles per floor. And what we'll find is that there are more door cycles at the lobby in an office building than there are at the top floor. So we should do more maintenance on the lobby doors, or do maintenance more often on the lobby doors than we do on the upper floors. And then another type of maintenance that became interesting about 20 years ago was called condition-based maintenance. And condition-based maintenance is we put sensors, instruments on the equipment, and then we monitor such things as vibration or temperature or anything that gives us an idea of what's happening with the condition of the machinery, and then using that we base our maintenance based upon what is the current condition of the machinery and what's its projected remaining life. But this is not something simple because it requires a lot of sensors to do properly, and it lends itself very much to machine learning in IoT. And then there's another type of maintenance that now is possible with IoT and machine learning, and that's predictive maintenance. That's where we are able to make predictions based on the data we're gathering of when a lift is going to fail. We may find that after we can say, well, in the next 2 weeks, this lift is going to fail due to a door problem. So then we can issue an alert, send a technician there to service the doors, and basically fix them before they fail. And then the next step beyond that is called prescriptive maintenance. Now, prescriptive maintenance is probably the highest and best use of IoT and machine learning, in that in this case we prescribe what the technician is going to do and when he's going to do it. So in the morning he goes to his computer and he logs on, and it tells him these are the addresses you're going to today, and these are the tasks you're going to perform at each address. So you're only going to do what needs to be done, nothing more, and it's not up to you, the technician, to decide what needs to be done. It'll be decided by the computer. Might give you some personnel issues to deal with, but it's a very effective way, and you're going to see much more of this. So what are the goals of IoT? What do people really want? It depends on who you are, what you want. So there's a couple of perspectives. One is the building management perspective. What does the building owner really want? And we've interviewed a lot of building managers and talked about what is it that's really important to them. And they want to know which lifts are in operation. And they want to know when a lift breaks down. Kind of makes sense. Customer says, a client in the building, tenant in the building says, lift number 3 is out of service, and the manager can say, yes, I know, and the lift company will be here in 7 minutes to put it back in operation. So that's very important. The other thing that's important is, if a lift is down, is it occupied? Because that's the beginning of lots of customer problems and of certain liabilities as well. Now, the perspective of the lift maintenance provider is quite different. What do they want? Well, they only want 2 things. And one of them is customer satisfaction. The idea with customer satisfaction is satisfied customers pay their bills, unsatisfied customers don't, and satisfied customers renew their service contract when the contract expires. So this is in the best interest of the lift companies to have happy customers, and IoT allows you to do that. And they also want operational efficiency. That means they want to run their operation in the most efficient way. They don't want to answer trouble calls if they don't have to, because they want to get there and fix it before they fail. They don't want to have any wasted steps. And so the use of machine learning can allow them to do that. So those are the different needs. They're quite different. and yet both of them need to be addressed. So I looked at a series of products that are available for the lift industry that are in different parts of the lift industry, but what's available targeting the lift industry. And the first product I looked at was an industrial router IoT gateway. Now, what is this? Well, it's simply an industrial router that's connected to a VPN for security, and it can push data to the cloud in either a wired format, let's say an Ethernet connection, or through a cellular modem. All it is a communication device. So in order to make this work, what you really would need then would be a team of engineers, data scientists, and domain experts to develop the front end of what are they going to gather, and then to do the other end at the cloud, what are we going to do with all this data? And it's very important to have domain experts. Now, what's a domain expert? Well, a domain expert is an expert in lifts or escalators or both. And so the idea is that you have to make a team so that the data scientists are gathering understand the meaning of certain things, understand and the only person who can do that for them is a domain expert who understands the technical aspects of the lift industry, but also the operational aspects. Another product I looked at is a remote monitoring system, and this system provides a graphic display for the building manager of the motion of the car, the position of the car, the motion of the car, the operation of the doors, and it also gathers usage statistics and creates usage reports. It issues alerts by text or email if a car is out of service. And so it requires a read-only interface where it's connected into the controller to gather this information. The product meets the goals of building managers because it lets them know the three things that the manager wants to know. Are my lifts running? If one is broke, they want to know when one breaks down, and they want to know if the car is occupied. And this system also has the ability to communicate with passengers, so you can ask them if the car is not running or is there anybody inside, or they can monitor microphones. Another product I looked at is a condition-based monitoring product. And this product consists of an accelerometer that measures travel, ride quality, door operation, and load weighing device that looks at car load. It can look at leveling. It has current sensors, so it can look at shaft efficiency, the number of trips that the lift makes, the duty cycles, and also the traction shift condition. It has a lot of sensors. There's a lot of data. So usage-based and condition-based maintenance are possible with this product. It's connected to the cloud with some machine learning processing there. Don't know how much. And it's designed for the lift maintenance providers, but it also can provide the information that the building management people want. Another product I looked at is a remote monitoring system, but it also has a command and control function. What does that mean, command and control? It means the ability to do remote intervention, to actually operate, cause the car to move and do things from a remote position. So it consists of a cellular modem and a car top module. The car top module has an accelerometer, plus it has two outputs connected to the top and bottom car call in the car. So the accelerometer monitors the car and the car movements, the door movements. And if no movement occurs for a certain period of time, when you would expect to have movement, let's say rush hour in the morning and the car doesn't seem to be moving, then it sends a car call to cause the car to run. So it pins the car to the top of the hoistway, the bottom of the hoistway, and if it doesn't see a run because it's monitoring it, then it will send an alarm that says this car is down. The unit is connected to a cloud, and so usage and condition-based maintenance are possible. And since it's in a cloud, there's some machine learning that can be done using the data that's pushed there. Another product are the products of the Western manufacturers. And so the multinationals, the Western multinational manufacturers have partnered with IBM Watson, GE Predix, and Microsoft. Two with Microsoft, one with each of the others. Their products gather large quantities of data and push it to the cloud. Their partners provide the data processing, the cloud processing, the machine learning, the data storage for this data that's being collected. And they don't do it for free, by the way. And then these companies, however, must develop their own machine learning algorithms. And that means you're going to have a team of data scientists and domain experts. And the interesting part of this is that the quality of the teams determine the quality of the product. If you don't have a strong team, you're not going to get a strong product. If you have a good mix of data scientists and domain experts, you'll get a good product. So, what are the conclusions? Well, the most important one is none of these products deliver all the magic. None of them do all of it. Most deliver some magic. And remember, different people need different quantities of management, of magic. If you're the building management, you want one kind of magic. And if you're the lift maintenance provider, you want a different kind of magic. But the suggestion is, before deciding on an IoT solution or recommending one to your clients, ask for a live demonstration. Why a live demonstration? Well, sadly, PowerPoints facilitate myths. And so it's very important that not to watch a great PowerPoint that tells you all the wonderful things that can be done. See for yourself, ask for a live demonstration, and find out, does this meet the needs of what I need for my building? Thank you.